Hey class, as y'all can see in this first unit that a lot of vocabulary is being thrown at you this first week. So it's going to be important for the rest of the course to become familiar with this vocabulary in this first week and make sure that you can recognize terms and things that we'll be seeing in future weeks of the course. So one of the topics covered is the difference between descriptive versus inferential statistics. And so I started out here with just the definition from your textbook of statistics. Based on your textbook, it is the science of conducting studies to collect, organize, summarize, analyze, and draw conclusions from data. So what I hope y'all see from the definition is that statistics actually encompasses a lot of different functions, a lot of different actions and activities. And so the basic concept is that we rely on samples because often we cannot reach entire populations because they're so large. But instead of just saying, oh, I guess we'll never know anything about the population that we're interested in, instead we take smaller random samples typically from the populations that we're interested in, and we study those samples by first collecting data for our sample, organizing the information in the sample, and summarizing it. So what I want you to see then is that these first few terms, collecting data, organizing that sample data that we collected, and summarizing that data, are all three parts of descriptive statistics. And the key thing there being the sample. We do this with our sample data. But then from the sample data that we have and the information that we have gained from the sample data, we then use that to make predictions and draw conclusions from the data. And so our conclusions or estimates or predictions are parts of inferential statistics. So this part, drawing conclusions from the data, is the inferential part. We're trying to use our sample information to infer what might be going on in the population. Actually, I meant to put inferential. Inferential statistics right here, drawing the conclusions from the data. So this is inferential statistics, but the collecting and the organizing, summarizing, and even the analyzing is part of descriptive statistics. All right. So that's fine. It's like we look at a lot of definitions in this first unit, but the important thing besides just learning the definition, honestly, of even more importance is that you can apply that definition. And that's where we want to look at some examples. I will go ahead and show you that by definition, again, from your textbook, descriptive statistics consist of the collection, the organization, the summarization, and the presentation of data. But I want to add to that really the key thing is all of this is coming from an actual sample of data that's been collected. Okay. So as I go through some examples with you in this short video, I want you to realize that if I end up saying that I believe that an example is an example of descriptive statistics, then I'm going to specifically be looking for the fact that it seems to imply that a sample is being summarized. Then with inferential statistics, by definition, again from your textbook, consist of generalizing from samples to population. And that is, of course, where we rely on these estimates and hypothesis tests, which we're actually not going to cover in this course, but if you take other statistics courses in your programs, you'll see more of that. But we rely on the samples to then make estimates or predictions about the larger population. So we will look at examples, and anything that sort of sounds like, it sounds like they're estimating, or it sounds like they're predicting what's going to happen, then I want you to realize that that is going to be an example of inferential statistics. All right, so with that in mind, let's go ahead and look at some examples that will be similar to your homework and to your quiz that you will take in Unit 2 that covers both Unit 1 and Unit 2 material. All right, example 1. The mean salary of a random sample of 60 high school teachers in 2012 was $54,820. The key thing I want you to notice here is this mean salary is from a random sample of 60 high school teachers. That's the key thing. That obviously data has been collected from this sample and is being summarized by this sample mean, and therefore the key thing with random sample information is that this is descriptive. So when you can tell with the examples that it's information from a sample, it's going to be descriptive statistics. Example 2, the median rating of Big Dave's Burger from 28 reviewers on a scale from 1 to 5 is 4.2. Well, it's a median, but the fact of the matter is the more important information here is that it's a median that came from a sample of 28 reviewers. So similar to example 1, we can attribute this number that's being given in example 2 to a number that has been summarized from a sample of 28 reviewers. Once again, that's the key piece of information that lets me know that this is an example of descriptive statistics. Third example, based on a survey, the mean weekly hours of TV watched by teenagers in the US is 8.8 hours. Now, I think this one's kind of tricky. For one thing, it says based on a survey, and that may make you tempted to want to say, well, that's from a sample, so I'm going to put descriptive. Well, it's correct that the information is coming from a sample because it did say based on a survey, but the rest of the writing is not implying that this mean is from that sample. In fact, it's basing the information from a sample, but it seems to be implied that now they are using that survey information to estimate the mean weekly hours of TV watched by teenagers in the US. So in other words, teenagers in the US, there's no way that was the sample because to try to reach all teenagers in the US, that's way too large of a population. You're not going to be able to reach it. But yet this mean weekly hours is being inferred that it's being the mean for all teenagers in the US. So even though it's been based on a sample survey, it's really a prediction or an estimate of what the mean weekly hours of TV watched by all teenagers in the US would actually be. So it's tricky. Key thing to notice though is it did not have a specific number of people in a sample that gave that 8.8 hours. It just sort of vaguely said based on a survey, so based on a sample, and then the implication is that, okay, here's our estimate of what the mean weekly hours of TV watched by all teenagers in the USA is. So this is going to be inferential because it's really just an estimate that's based on a sample. And our last example. In 2030, City A's population is expected to be 1.2 million. I think this one's a little bit easier. Obviously, the 1.2 million did not, the information may have come from a sample that led to this, but you can clearly tell because it's saying in 2030, the population is expected to be this, then that is expected to be this number is a little more clear that this is an estimate or a prediction about what's going to happen, and therefore it is inferential statistics. So hopefully from this short video, you can tell that it's really a matter of reading the examples carefully and saying, did this number come directly from a sample? Is it a sample result, a sample figure? Or maybe did the information come from a sample, but yet now it's being used to allow us to estimate or predict what's going to happen in the bigger population? And if that's the case, then you would want to say that that's an example of inferential statistics. So I hope that's helpful with helping you with these two vocabulary words this week, and good luck to you.